It's a few weeks later, and as you saw there in the end of part one, my camera battery died right when I was drilling this out in the lathe. But I did manage to get it drilled out. I had found a drill up to 1 1/8 inch. Got it drilled, and then I finished boring the rest of it, which was a boring job. But I got it pretty good. I was kind of concerned with inside finish, and I kind of went just a tiny bit over. So it's got just a little bit of rock, which not really desirable. But at this point, I got a couple other operations I might screw up, and I'll get a chance to remake it. Otherwise, if it works, I guess it'll be good enough for me. So we'll just have to see how it goes when I actually go to press something and see if that flex, being way out here where the ratchet's going to be, is really a concern on the length of the shaft or not. I don't want to modify the original shaft because this is where the original handle goes, and you can always take off, what I'm building, and just go back to an original handle if you want. So what I've laid out is I've kind of laid out the box that should be the square, the 3/4 inch square to fit a ratchet, and then I'm going to come in. I think the only end mills I have, there's about 7/8 worth of thickness here of material to accommodate the end of the ratchet, so it wouldn't come in and contact the end of the shaft before the ratchet got flush with the end of this. So the only end mills I have that will reach that deep are 1/2 inch end mills. So I think what I'm going to do, what I've laid out, is to come in with an 1/8 inch drill so it just barely fits in the corner, and to leave that little radius that I can hand file out of there. And then I can clean up the rest of the material with one of these 1/2 inch end mills, hopefully, and it'll come out nice and square. So I'm going to go over to the mill and get started on drilling these holes and then mill it out. And if that's successful, then we'll come back and we'll look at how and where to make the hole, and probably make a new pin for this. I was looking at hitch pins like at the hardware store, and I wasn't particularly impressed with their fit or their finish. So I have a piece of 4140 that I bought for a project a couple years ago and never used. So maybe we'll make a little hitch pin style pin to go through here, and then I have the a set screw that will go in here, and once this is on, it'll come in and lock against that pin, which will lock this on. And when we drill this, and we can kind of counterbore it so the pin will fit down in there. So that's where we're at. Meet me over at the mill. At the mill here, I've got my my piece set up in my vise. And what I did was I took this 246 block and laid it up here. And I took one of my little squares, and that helped me sort of eyeball lay out the grid that I've scratched there to double check myself when I do this. And then I found the center of the hole with my coaxial gauge here. You can see it's pretty centered. So now the plan is, and I've zeroed my dials, and I don't have a DRO, so I zeroed my dials and left myself little love notes as to which direction I was turning when I zeroed them out. So hopefully I can, it'll help me deal with the backlash. But the plan will be to take this out, go to a center drill, come over, come up, and see if we can get the first one in, and then work our way around the box, drill the holes, and then hit it with the 1/2 inch end mill to clean it all up, do whatever file work is necessary to get the ratchet on there. So let me get this set up, broken down, and we'll get started on drilling the holes. I've got our first hole lined up and spotted. Appears to be in the correct spot. So I'm going to go ahead and drill it. I'm going to try some of this OD dark thread cutting oil. Picked it up at Home Depot. Saw some people online like to use this stuff for lathe and mill operations, so I thought I'd give it a little bit of a try. Alright, I'm going to drill the other 3, and then we'll come back when it's time to get in there with the end mill and work on squaring this up. Alright, so I ended up doing the milling of the pocket off camera, trying to remember everything I was doing, and then also film and talk and everything at the same time was just kind of too much. So this is where I'm at. I've kind of took that 1/2-inch cutter and milled it in. Hopefully you can see some of this paper there. So what I'm going to do now is spend a little time with a file and work the sort of the rounded corner in front of the drill holes out to square with the drill holes. We're pretty close. The sizes are right there. We're just within a few tens of thousands, I think, like 20 thousandths one way, 30 thousandths the other way that needs to come out of there. So it should be perfect, I think, after I file it. And then just constantly checking it to make sure it fits on the ratchet, and once it does, probably call it good. So I'll bring you back after I do the file work and get it fitting onto the ratchet. Okay, I spent some time with the file and got this pretty well filed out square. Let's see if I can, well, you guys can see that. It's not too bad. You can still see some of the marks in there from the end mill. I guess I should have left myself a little more room and not came quite as far with the end mill, but live and learn. I'm not a machinist. I'm barely even a hobbyist when it comes to machine stuff. First time I've ever attempted to do anything like that with machine tools. It fits on the ratchet pretty well. Gets down, slides right on there to about the point where the little ball is that helps latch it on there. So I think it gets pretty tight. So if you look at one of the sockets out of the 3/4 inch set that I have, they've got this sort of dished out feature there that I think helps get that ball to slide in, and then also inside, which you probably can't see, is they have some detents in there, I think, for that ball to, that's where the ball snaps down into those, and then it helps hold the socket on the handle. So I think that I can probably accomplish with a boring bar. I've been kind of eyeballing it and looking at whatever I have for boring bars and stuff, and I'll probably try the dishing it out and putting that detent in there last. I think the next thing I really want to work on is making the pin for where this they'll hold this onto the shaft, and then a set screw goes in and then locks that pin in. And that's how the original handle was locked in. There's actually a thumb screw there. So I think I want to make the pin next, then locate and drill this hole, and then probably bore it out so that it can countersink a little bit. So make the pin and make it a little long on both ends, and then possibly, depending on how it goes, put that pin in there and see if I can fix it in there somehow and maybe turn it down so it's even smooth on the outside. I don't know. I guess we'll see how it goes. But right now, actually, that piece of steel I had is 4130 normalized. So I've already got it mounted up in the collet chuck on the lathe, and I just want to get started turning the pin down. This hole right here measures out at about 0.649. So just something that allows a nice slip fit down through there, because then the set screw is going to hold it in place anyway. But so let's go over to the lathe and we'll get started making that pin. Alright, gonna face this off and then come in here and find a length and start turning this down to diameter, and then I don't know if I'll part it off or maybe just cut it off in the bandsaw, but leave a head on it, flip it around, face that off, and then we'll start working on boring the hole in the other part. So let me do. Just a tiny, tiny little pip there. Alright, so I ended up coming in here and having to skim another couple thousandths off, and then did a little bit of polishing, and I got a pretty good fit here. I think there's just a little bit of, I don't know if you can even see it on camera, tiny bit of rock, and I think that'll work. It says screw's going to come in here and lock that shaft in there anyway. So I think what we're going to do is go ahead and trim this down to length, chamfer that corner, and then probably just cut it off in the bandsaw, come back and face the head off, and I'll chamfer this corner too, and then we'll start working on boring the hole through the socket piece and keep on working. Here's our pin, hot off the bandsaw, literally. Just gonna put it in the 3-jaw here, face off the top down till this is 1/8 of an inch, and then we'll be all done with this pin. .126. I think we'll just polish in with a little emery. Call it good. Break that corner a little bit. And we have our pin. Alright, let's go work on the hole that it goes in. Okay, so we've got our parts. We've got our pin here to go through the pinion shaft. And we've got our socket to go on. I've measured this multiple times, so the depth of, or the width of the material that's still in there on the bottom to this, I've come up with 1 inch 723. So I've made my scribe mark here. Just want to get used to the Arbor Freight calipers versus my good Toyos here. I use them for precision scribers. So I've got my mark. I'm still going to put it in the mill and you know, take the edge finder and everything, but I just want to make sure that I have a mark there to double check myself. And then we'll work on drilling the hole through there. So I'll get the mill cleaned up from our earlier work of squaring this up. And I'll get it set in there and we'll get ready to drill this hole. And then if that's successful and everything lines up correctly, we'll come back and we'll look at dishing this out. And also making the detents on the inside for the little ball on the end of the ratchet. So let me get this set up and we'll get started. Okay, I've got this set in the vise on a couple of parallels. I don't have V-jaws or anything like that, or even V-blocks. It's in there pretty firm. I used my center finder and then measured it every conceivable way I could think of to make sure that that hole is, you know, where it needs to be both ways and perpendicular. So at this point it's just go for it and hope we don't turn this into scrap. So I'm going to drill it up to 9/16, and then I'm going to use my that should give me enough clearance to use my boring head that I have to get it up to the diameter, because I don't have a drill bit or a reamer that's anywhere close to the diameter we need. So going to just go for it. Okay, we're through the first layer. I don't have a lot of clearance below the part, so I need to be really careful when I break through so I don't drill into my vise. I think I guess I'm about ready to go through. There we go. This one is 7/16. Okay, so last night I worked on drilling and then boring the hole through this piece for our pin. I didn't have a drill bit anywhere close to the size of the pin, so I drilled it as big as I could, and then used my boring head to bore the rest of it. That's one of the downsides to the millwright mill, is it has no real good provision for boring. I don't even have the fine feed on mine. I have the drill press handle. So when I go to bore something, I have to do it with the knee, which is less than ideal. I mean, it does work, but barely. So we got the hole through there, and then I countersunk it a little bit right there. I happen to have an old 7/8 end mill, so I managed to give it a little bit of a countersink. This is the top of this is 7/8, so actually fits in there pretty nice. And our length came out pretty good. It's a little bit on both sides. However, when we go to put it together, if I put it together one way, I don't know if you can see down in there, but there's like a 16th, at least a 16th, actually it's probably more closer to an 1/8 at the widest, off. But then if you rotate it, it comes out aligned almost perfect. So, you know, I kind of assumed this hole through the pinion would be centered, and maybe it is. I don't have a surface plate and a height gauge and all that stuff to do a lot of forensic and machining, right, investigation to see what the problem is. But it comes out almost perfect. It was off maybe just a few hundredths, and it was not longitudinally. It wasn't off this way. It was actually off just a little bit to one side. So not sure what all was there, but I went in there with a 1/2-inch end mill and just kind of touched the side a little bit, took a few thousandths off, and right now it's to the point where if I beat it in there, it's just a really nice tight fit, and it locks this thing on there very solid. So I'll take it. Maybe it's not exactly according to Hoyle way of machining it, but I'll take it. Let me grab a punch. I got that in there just a little bit too tight, and I'll tap that out of there. So works for me. The fit is still pretty good on the ratchet. It does get very tight once you go down on there a little further, so I may have a little more file work. But the next thing I wanted to work on was, if you look at the back of a 3/4 inch socket, or probably any socket, they have this angle on here, which helps when you go to slide it on with the ball. Just kind of helps, I think, push that ball in, and then there's a little detents on the inside that the ball slips into just to help keep it on there. So the next thing I want to work on is replicating that dish here, this kind of angled in area, and everything I've been able to excuse me, been able to figure out so far. That's about 30 degrees, and then they just make an area that's just a little bit bigger than the points on the corner, like maybe an 1/8, not quite an 1/8. So that's what I want to do next. I'm going to go over and get this chucked up in the lathe. Okay, so I've got this checked up in the forge jaw. It's within about a thousandths, a little less than a thousandths. I've kind of hand scratched a line about where I think I want the circle to come out to, and I couldn't really find a good piece of high-speed steel that looked like it would be good for this application, and I don't want to take the time to grind one right off, so I thought I'd try this insert anyway, and we'll just kind of see how it goes. Got the compound set to 30 degrees, so I'm just going to feed it in and you know, take a little bit at a time and just see how it goes here. So let's get started. Seems to be cutting okay, so we'll just keep going. Certainly not leaving the best finish, but looks pretty close to what a normal socket has on it. I think I may just, I don't really want to poke my finger in there with some emery cloth, so find a stick or something and do a little polishing on that. Be right back. Found this little piece of plywood scrap. We'll see if it'll work. So it'll probably work. I'm just going to speed the lathe up here. For something that's going to be hidden behind a ratchet all the time, I think that's good enough. I'm going to go deburr that a little bit with a file and clean it up, and meet you back over at the bench. Alright, over here at the bench, maybe you can get a little better shot of the what we did there. And do a little test fit. And she snaps right down on there. That helps quite a bit to push that ball in and let the socket slide down on there. And then fits on there pretty well. Comes off alright. I'm not sure I want to venture into trying to do the details for the ball here on the inside just yet. I don't think I have good tooling for it. I've been kind of looking at it, and I think it might be tough to do, or tough to do well. I'm not sure as tight as that really fits. I mean, it's just going to be on the Arbor press, that would be any kind of a problem. So I think I'm just going to move into the assembly stage here. Alright, now these have oil holes for up here, so I'm just going to put a little bit of whey oil in here. We can install our feed shaft. A little spin, oil hole. And then this is the collar that holds that in place. And there we go, the shaft's in place. So next, going to like grease, and I'm just using some red EP grease that I have. I'm gonna get that collar just a little snug here. There we go. Alright. And this one is the side gib plate, and we can see the old screw marks where it used to be in there. So I think I'm just going to put a little bit of grease on the back of it to, one, help preserve it, and two, help stick it in place here while we assemble. And here's the front one. Same thing, goes inside the cover. A bit of grease down in there. Help prevent that from rusting in the future, and hold that in place while we assemble. It's upside down. Now the bolts I didn't paint yet. I always get tool marks, it seems, on the bolts, you know, the paint anyway. So I like to just give them a quick hit of paint after everything's all done. Check all those with a wrench here. And time for cube screws. Run those until I just feel the screw make contact with the plate, make contact with the ram. rub the wrench to snug down the nuts. Pretty good. Very nice, I think. All right. Let's get our ratchet put on over here. I think that's going to work out pretty well. Now I noticed Chuck Bomarito, who I got this idea from, he ended up putting a hand wheel over here in place of the collar. He happened to have one, so I think that would be a pretty good idea. If I can find one, it'd have to stand out a little bit too. It'd need something of a bit of a standoff, because otherwise it would hit the this piece here, the flange, whatever that is. So, but let's give it a try, shall we? Okay, so thanks for coming along on this adventure with me. I think this is going to work pretty good. For now, this will probably find a home over on my bench. Future project, I'll have to look for a piece of plate or something to mount this on, and then probably make a stand for it. Excuse me, I'm kind of running out of room down here in the bottom of my shop. I'm kind of realizing I have to start putting stuff upstairs, which is an unfinished area. So I'd have to make a stand or something to put it on, because there's no benches or anything like that up there. But thanks for watching, and I hope to do more projects for you in the future. Thanks.